All right, we're going to look at the next 10 problems on your review. It says the conjugate of the complex expression negative 3x plus I. The conjugate of a complex number or a complex expression that looks exactly, this is in a plus bi form, it looks exactly like this guy here. Notice the quote real part first, the imaginary part second, a plus bi. Okay, all we do is we change the sign in the middle. We leave a the same, we leave I the same, but we change, or b the same I should say, but we change the sign in the middle. So this becomes negative 3x minus I. Negative 3x minus I. And I don't have my paper in front of me. Shame on me. That would match up with, let's see, guess it would help if I was organized. Trying to get to that, and this is number, there it is. That would be answer A. All right, the expression the square root of negative 50, which is imaginary because the square root of negative, over the square root of 2 is equivalent to, now you don't want a radical in the denominator, but here's the good news. The square root of negative 50 can be thought of as negative 25 times 2, all over the square root of 2. The square root of negative 25 is 5i. The square root of 25 is 5. The square root of negative 25 is 5i times the square root of 2. The 2 stays under, all over the square root of 2, which conveniently allows that to cancel out, and I just get 5i. And that matches up with, looks like answer C. Problem number 13, what is the product of 3 plus the square root of negative 36 and 1 minus the square root of negative 49 is expressed in simplest a plus bi form? Well, negative 36, the square root of that comes out to be 6i, because this is, the square root of 36 is 6, the square root of negative 1 is I, so this comes out to 6i, and that's going to be multiplied times 1 minus the square root of negative 49, which is 1 minus 7i. The square root of 49 being 7, the square root of negative 1 being I, 7i. So now I'm just going to do a FOIL, kind of a FOIL approach to multiplying these imaginary numbers together. So first, outer, that'd be minus 21i, inner, that would be plus 6i, and then last, a positive 6i times a negative 7i is a negative 42, careful, I squared. Now these two guys are like terms, that's negative 15. Negative 15i, I should say. The 3 is not a like term with it, but what about this I squared? Well, you should have this memorized. The I squared is equal to, if I can write it, is equal to negative 1. So this is minus 42 times negative 1. This is going to be plus 42. Now they wanted an a plus bi form, so add the real parts. That's 45 minus 15i, and there's your a plus bi form, and hopefully it matches up with an answer somewhere. And if I could read my own handwriting here. Oh, good. Minus 21 plus 6. No, that's a minus 15 there. I am not matching an answer. I must have this written down incorrectly. Oh, I sure do. This is a 5. I guess it helps if you write it down right. So this is a 5. Oh, sorry. So sorry about this. So this is a 5. And 5 minus 7i would be minus 35i. And that would be minus 25i. And there it is, minus 25i. And that matches up nicely with answer D. It just took me forever to get there because I wrote the problem down wrong. I wish I could say I did that on purpose just to keep you on your toes, but I didn't. All right, when you have I raised to a power, you must remember that, of course, that I to the first is I, or the square root of negative 1. I to the second power is negative 1. I to the third power is negative I, and I to the fourth power is positive 1. If you can remember those, this is not so bad, because all you have to do when you have a positive exponent is to divide the exponent by 4. 4 goes into 10 twice with 2 left over. Whatever the remainder is, 2 left over, that tells me that I to the 10th is equal to I to the second. Because this is a cyclic a pattern here with the powers of I. And so what happens here is I to the 10th is equivalent or equal to I to the 2nd, which is -1, and hopefully that's one of the choices there, and that's answer B. Okay, now if this was a -10, all right, well, I'd be a little more careful here. Now, as it turns out, it would still work as far as the division, but what I would probably approach this as is if I have, and I'm running out of space, so I'll kind of bring it up here, I to the -10 can be thought of as I to the -12 times I squared, because you would keep the same base, add the exponents. I went to the largest multiple of 4 less than or equal to this exponent here, because it's negative. -12 is the largest multiple of 4, integral multiple of 4, that's less than -10. I to any multiple of 4 power is 1. And 1 times I squared is -1, so that's -1. So be careful if they have a negative exponent especially. A positive, you can use a little division trick, but with a negative, you're better off thinking of it in this terms. All right, the next one looks like good old FOIL. Here it says the expression x minus 4 quantity squared. Hopefully this is good old FOIL. Looks like that. I don't see any i's or anything in there, so I'm just going to write it twice and do FOIL. Now you should know the pattern. You square the first term, you keep the same sign, you double the product of the first 2 terms, then always, always, always a plus, and the last term squared. Or you can write it twice, that's x squared minus 4x plus 24, or plus 24, plus 16. Combine your like terms, I have x squared minus 8x plus 16. And that matches up with one of the answers, I hope, and it looks like answer C. All right, problem 16 says one of the factors of this trinomial, 6x squared plus 5x minus 6, is 3x minus 2. The other factor is what? Well, you can do this 2 ways. It's a quadratic, just divide into it, do long division, this dividing into this. But since it's a quadratic and you have one factor, that means if you just take 6x squared plus 5x minus 6 and attempt to factor it, you're going to get 2 linear factors and you already know one of them. It's 3x minus 2. What here in the first is going to give me 6x squared, well 3x times 2x. What's going to give me the minus 6 on the end? Well, times a -2, that would have to be the L, would have to be a positive 3. Then you can do a quick check. Plus 9x minus 4x is plus 5x for the middle. And so that would be 2x plus 3 being the other factor, and that's answer C. What are the solutions for this quadratic equation? Well, when I have a quadratic equation, even though it's written like this, because the problem is almost like crying out, complete the square, complete the square. I would probably subtract 16, because I prefer, if I can, to factor. Now, if it doesn't factor, I could go back to the original and complete the square, or I could leave it like this. A is 1, B is 6, C is -16, and use the quadratic formula. X is equal to the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So you need to have that memorized. By the way, that's a really good thing to memorize. I think in my last video, I'm going to write down all the different formulas I used in the process of solving these problems out. I'd make a list of them and put them to memory if you don't already have them. Because typically, the problems on an exam, not always, but the problems on the exam are similar to the problems from the review. So if you see it in the review, you could very well see it in the exam. This is going to factor to an x plus 8 times an x minus 2. If you don't like factoring, use the quadratic formula. I'm going to set x plus 8 equal to 0. I'm going to set x minus 2 equal to 0. That's the zero product property. This times this gives me 0, only if this is 0 or this. And if I solve these little linear equations, I get x equals -8. And over here, if I add 2, I get x is equal to positive 2. And those are my 2 answers, and hopefully they are listed. And it looks like positive 2, -8, answer C. 3 C's in a row. Okay, that's weird. All right, the next one up is problem number 18. Which of the following quadratic equations is solved correctly? Well, they kind of want you to approach each one, but as it turns out, every once in a while, you know, the math creators of these problems smiles down on you a little bit, and it works out for the very first one. This factors to x minus 7 times x plus 5 equals 0. If I said x minus 7 equal to 0 and x plus 5 equal to 0, I get x is 7, I get x is negative 5. And that looks like that matches up pretty nicely with answer A as being the correct one. If you go through the other ones, you will find at least one mistake. For example, in part B, they factored it right. That's x plus 6 times x plus 1. But when you set x plus 6 equal to 0, or x plus 1 equal to 0, you get negative 6 and negative 1. And they have positive 6 and positive 1. If I do this next one and factor this, I have x squared minus 9x minus 18. Well, the trick here is that it doesn't really factor very nicely. And, you know, if you try to do the factoring that they give you, x minus 6 times x minus 3, I mean, it kind of looks like you get the 18 and you get the 9. But negative times negative is positive, and that's a minus. So no good. No good. And the last one, I think they factored it. Yeah, they factored it incorrectly. It looks right, except that they have the wrong signs. They have an x and an x, and they have a 4 and a 5, and that's going to work to give me the 20 and the minus 9. But they have to both be negatives to get the minus 9 there, not positive. So that throws that one out. Again, it's answer A. 19 says, what quantity should be added to both sides of this equation to complete the square? This one is actually kind of nicely set up. The two terms that have the variable are on one side, the constant terms on the other. That's good. The lead coefficient of my x squared term is 1. That's very good. So the trick is you go to the coefficient of the x and do two things. You take negative 8, because of the minus, negative 8. You take half of that. Negative 8 divided by 2 is negative 4. And then you square it. Negative 4 squared is positive 16. So I'm going to need to add 16 to both sides. But they don't want you to finish the problem. They just want to know what number is going to be added to both sides. It's answer C, 16. Now the last problem, you could do this a couple ways. It doesn't factor. So you either have to like subtract 53 and kind of start it like this problem here by completing the square. Or you can jump right to the quadratic formula. Now you're going to have a decent sized number in there because C is 53. But that's up to you. I'm just going to show you one example of completing the square. So I'll subtract 53 from both sides. And watch, I'm going to be lazy and I'm going to leave a space here to complete the square. See how it's a lead coefficient of 1? Half of that squared is a positive 4, so I'll add 4 here. And I get the quantity. This is a perfect square trinomial, so it can be written as a binomial squared. That's what a perfect square trinomial means. So it's an x, and 2 times 2 is 4, and I need a plus 4x in the middle, so a plus right here. Negative 53 and 4 is negative 49. Now I have to take the square root of both sides, because I've got to get rid of the square to solve for x. Here's where you would pick up the absolute value of x plus 2, because we don't know if x is positive or negative. Over here, we get 7i. We had that guy once before, back here, the square root of negative 49. If I drop the absolute value, I get x plus 2 is equal to plus or minus 7i, and then I'm going to subtract 2 from both sides, and I get x equals, now you can't subtract those because they're not like terms, you have negative 2 plus or minus 7i, so that's negative 2 plus 7i, negative 2 minus 7i, and that matches up with answer A. Alright, so not quite halfway through this. We'll be doing some more here as soon as possible. Study this stuff. Practice it.